Okay, so we have to deal with solving these problems. We're going to make a what we call a VIR table for each of these. And when we do this, we need to know, all right, that we're dealing with all series circuits. You need to know that you guys already should have this written down. This is for people that aren't here. The total voltage, VT, is equal to the voltage drop across resistor 1, across resistor 2, and however many there are. The current, which is I, total current is equal to the current going through resistor 1 or resistor 2 or, I'm sorry, no, not plus. They're all equal. So once you know it at one spot, they're all equal, and however many resistors you have. And then the total resistance, sometimes called REQ for equivalent resistance, they're the same thing. It is equal to all the resistor values added together. Right? Now, what we're going to do is for number, I'm going to call this guy 1, 2, 3, 4, 5, and 6. So we're going to take a look at number 1 together. So on a separate sheet of paper, you guys are going to want to make these because it's definitely not enough room right here. Make V, I, R. And now, based off of how many resistors we have, we write that number here. We have 2. So we're going to write 1, 2, and then after that, we need 1 for the total. So you write a T. You also need to make sure that you are using Ohm's law. V is for voltage, measured in volts. R is resistance, measured in ohms, which is like this little upside-down horseshoe-looking character. And I is current, measured in amps. Okay, so now, with all of that, let's do it. First thing you got to do is write in what you're given. What am I given? I see R1 is 10. So I'm going to write that in for R1. I see R2 is 20. Going to write that in for R2. I don't see anything else except for a 90 volts. Why is it in this little line? This is basically just telling you the voltage across that spot. Since it's over the battery, this little symbol is a battery. Anytime you get a symbol or you get something volts right next to the battery, that means that is your total voltage, VT. So we have 90 volts here. Okay, so right now you guys, you need to deal or use, all right, the rules for a series circuit in combination with Ohm's law. You can only use the triangle if you have 2 pieces of information in either row, in any row. So right now I'm missing 2, I'm missing 2, I'm missing 2. I need, in one of the rows, I need at least one other piece of information in order to use a triangle. So, let's see, VT is equal to V1 plus V2. I can't add these together because I don't know what they are yet, so I can't use that. Current. Well, if I know the current in any one of these spots, I know it's going to all be equal, but I can't use that. So I'm going to use RT, which will be R1 plus R2. R1 plus R2. So that's super simple. I'm not really needing to do the math. I'm just going to show it anyway. So 30 ohms. All right, 30 ohms is our total resistance, which you just found by straight up adding. All right, 10 plus 20, boom. Now I have 2 pieces of information in the same row, which means I get to use the triangle. So I need to use this to find I. I is equal to V divided by R. Now you have to make sure you're using everybody in the same row. So I use the subscripts here. I use IT is the total current is equal to total voltage divided by total resistance. So 90 divided by 30. And that gives me 3. And the unit for current is an amp. A. So we have 3 amps. Awesome. Problem. I don't know what to do from here. I'm missing these pieces of information. How the hell am I supposed to find V1, V2, I1, and I2? Well, let's take a look at our rules again. Current total is equal to the current going through resistor 1, going through resistance or resistor 2. Why? Because the current really only has one pathway to take. It only has one pathway to take all the way around. So that is why once you know it at any single point, any series circuit is the same everywhere. So no math is needed. Basing off the rules, these dudes, 3 amps, 3 amps, and 3 amps. Now, what's great is now that I have I1 and R1, I can find V1 using the triangle. Triangle says V is equal to I times R. So I times R, doing I1 times R1, 3 times 10. It's going to give me 30 volts. Now you can do this next one 2 different ways. You can do this next one 2 different ways. If you know that the total voltage is V1 plus V2, I can literally do, realize I already know what the total is, so I could do 90 minus 30 and figure out that is 60. Or, using the triangle, I times R, I2 times R2, 30 times 20, or 3 times 20, and that is 60 volts. Remember that when you do this, the total voltages need to add up to be the total. 30 and 60 adds up to 90. Boom, great. So yes, 100%. This dude is 60. So you make a Veer table for any of these, and it will wind up working. So the next one is going to be done the same exact way. There's just a third resistor. Let's take a look at something that you may not have seen yet. You may not have seen number 3 because that looks slightly different. So let's see, you can leave a space here for 1. Let's see, space for 2. We'll start 3 down here. How many resistors are there in this circuit? 1, 2. So I'm going to write 1, 2, and then T for total. All right, what can I fill in? Well, this symbol right here is across the battery, so that tells me that the voltage across the battery, which is our total, is 75. What else do they give me? R1 is 10 ohms. R2, I don't know, what the heck does this mean? Well, that means when you see this symbol, again, over a resistor or over the battery, that's going to explain what that is. So since it's over resistor 2, this will become V2. So V2 is 25 volts. And there's one other piece of information, this little 5 amps dude here in a circle. What the hell is that? That is a symbol for an ammeter. When you see this symbol anywhere, all right, along a series circuit path, means the current's the same everywhere. So 5 amps, 5 amps, 5 amps. And then from here, guys, it's super, super easy. You have 2, all right, in each row for each, you have 2 pieces of information in each row, all right? So simply I could do 5 times 10 and figure that out right there. And that is going to give me 50 volts. Or I could have done, since I know that the total voltage has to be equal to these 2 added together, I would know that, okay, if that's the case, 75 minus 25 would also have given me 50, but it checks out. So we solve for that. And now it's very simplistical as well. If I want to know what R2 is, I looked at the triangle. Ohm's law's triangle says, covering up R, I'm going to do V divided by I. So I'm going to do V2 divided by I2. V2 is 25. I2 is 5. And I get a resistor here, then value of 5 ohms. Now I can find RT 2 ways. I can do the same kind of piece here. I can do VT over IT and do 75 over 5 and get 15 ohms, or remembering the rules, total resistance is all the resistor values added together. So I know that this is 10 and this is 5. If I added them together, that would also give me 15. Or 10 plus 5. Okay, again, either way works. So sometimes there's 2, or there can be 2 different ways to do something, or there can be just one singular. And then we could also just take a quick look at number 6. And we have 1, 2, 3 resistors, so we got 1, 2, 3, and then total. All right, what do we got? What do we know? Someone help me out here real quick. What piece of information do you know? R3. Okay, R3, we're writing in 10. Good. What else? We don't know what R2 is because we don't have an ohm value, but you saw this. Right? What letter is that? So it's going to go with V, and since it's over in position 2, it's going to be V2. So V2, we're going to have 10 volts. What other numbers do we have? VT, all right, which is 40, all right, because it's over their battery. And last one that we have, we have what? V3, because it's right over 3. And that is 20 volts. All right. So what do I do? What would your first step be? Someone tell me. Good, because V1 plus V2 plus V3 need to equal 40. Since I already know what the total is, I can reverse this. I can do 40 minus 20 minus 10. So 40 minus 30 would give me 10. This has to be 10 volts has to be V1. Now what do I do? Because I'm stuck. I don't know any current. I don't know. Yes, what would you do? Figuring out I3. Okay, that seems to be the right move. Why? Because I have two pieces of information in a single row. What is I equal to? According to Ohm's law, how do we figure out I? What are we going to do? We're going to do V divided by R. But it has to be, all right, everybody in the same row. So you can't use like 10 divided by 10. It has to be the dudes in the same row. So you got V3 divided by R3. So you're going to get 20 over 10 or get 2 amps. And once you know that, once you have this this 2 amps down, then what do I do? Correct. All right. In a series circuit, current is all the same. So these are all going to be 2. And from there, find R. R's are equal to V divided by I. So R1, V1 over I1, 10 over 2, and that's 5. The next one just happens to be the exact same thing. R3 would be V3 over I3. Oh, we already have that. All right, so let's see. We get then 5 and 5. So we could have done the last one. We could do 2 ways. You could do total, or the totals, 40 divided by 2. Or once you have R1 plus R2, or R1, 2, and 3, you can add them together to get the total. All right, 5 plus 5 is 10. 10 plus 10 is 20. This way it works out to be 20 as well. So there you go. You have solved for all pieces of the missing information. You guys are going to be tasked to solve. All right, finish the rest for homework. So you have to finish 2, 4, and 5. Okay, good question. So the back as well. Let's see. These guys right here, all right, at the bottom right there, these are resistors. So we can call this R1, we can call this R2. We can call this R1, this R2. R1, R2. R1 and R2, R1 and R2. That's pretty much telling you guys straight up. Okay, you need to find V2, just make a VIR table for each of them. All right. These little dudes here, don't freak out about them. They're just telling you, oh, it's the ammeters. All right. They're telling us here that if ammeter 1 reads 0.2. What should the other ones read? Well, based off of the rules, the ammeter should also read 0.2 amps. It should be the same everywhere on series. Determine the total resistance. All right, equivalent resistance is the same thing as total resistance. And then what is the voltage coming from the battery? So if you make a quick VIR table, you can do this, or for these ones, you don't necessarily have to. I just like to because it keeps everything nice and neat. But in this case, I already know what all the I's are. I know what I1, 2, and 3 are. That means I know what IT would need to be as well, 0.2 amps. They ask you to find RT, so 22 plus 15. What is that, 37? And then if I need to know the battery, I can use Ohm's law's triangle, which would be IT times RT. And I could do, which would be 0.2 from the amps. And the total resistance should be 22 plus 15. And then if I do the 0.2 times 37, I will get 7.4 volts. All right, so that is essentially, guys, what you're going to need to do. All right, so you now have questions. You have questions 1, 3, 6 done and completed. 1, 3, and 6. So you will complete 2, 4, and 5. Okay, make your VIR tables, please, off to the side on a separate sheet of paper. And then complete 2 and 3 on the backside as well. Okay, if they ask you for the voltage drop across each lamp, they're asking you for V1 and V2. All right, voltage cross, against each resistor. Again, they're asking you for V1 and V2. All right.